All right, let's dive into something huge today. We're looking at a brand new theory of gravity that might just turn cosmology on its head. It suggests that one of the biggest mysteries out there, dark matter, isn't a thing at all, but is actually a deep misunderstanding of space itself. So, to get started, we have to ask a pretty radical question, one that's right at the heart of this whole idea. What if dark matter, this stuff we think makes up 85% of all matter in the universe, what if it just isn't there? This is a starting point for our whole cosmic detective story. So, to really get why this new theory is such a big deal, we first have to understand the puzzle that has kept astronomers scratching their heads for decades. You could almost call it a cosmic ghost story. Okay, so here's the problem in a nutshell. When we look out at galaxies, they are spinning way, way too fast. Based on all the stuff we can actually see, stars, gas, dust, there just isn't enough gravity to keep them from flying apart. Think of a merry-go-round spinning so fast that the horses on the edge should be flung off into the distance. But for some reason, in our galaxies, they aren't. They're holding on. The question is, how?
For years, the main solution has been this. Well, this placeholder idea. A ghost in the machine we call dark matter. The theory goes that there's this huge, invisible halo of stuff surrounding galaxies that provides the extra gravitational glue to hold it all together. The only problem? We've spent decades building incredibly sensitive detectors to find this ghost, and we've found nothing. Zero. Zilch.
And this is where our new theory, known as QVP-G, steps onto the stage. It suggests we've been looking in completely the wrong place. The answer isn't some new kind of matter. The answer is in the nature of space itself.
You see, we tend to think of space as just an empty box, right? A passive, black backdrop where things happen. But this new idea says, no, that's wrong. The vacuum of space is an active participant. It's this dynamic, polarizable fabric that can actually react when matter is present. So space isn't just the stage, it's one of the main actors. Now, to get a handle on this, let's use an analogy. Let's imagine that the vacuum of space isn't empty at all. Instead, imagine it's filled, everywhere, with a sort of giant block of cosmic styrofoam. So what happens when you put some normal matter, like a star, into this cosmic styrofoam? Well, its gravity causes a reaction. It polarizes the vacuum around it, a bit like how a magnet can make a bunch of iron filings all line up. And here is the absolute key. This alignment, this polarization of space itself, generates its own extra gravitational pull. It's not new stuff. It's a bonus effect from the stuff that's already there. Gravity is a team effort between matter and space.
So, you might be wondering, how does a galaxy-sized effect like this even get started? Well, this theory says it builds up from the smallest possible scale. So let's zoom way in, right down to the level of a single atom.
Okay, so this is how we connect the tiniest scales to the biggest ones. It all begins with just one atom. Its tiny bit of mass creates a tiny little disturbance in the vacuum, a little polarization halo around it. That halo then adds its own tiny bit of extra gravity. Now, for one atom, who cares? It's basically nothing. But a galaxy isn't one atom. It's trillions upon trillions of them. And when you add up every single one of those tiny halos, that tiny atomic echo becomes a cosmic roar, enough extra gravity to explain everything.
But what is this cosmic styrofoam really? I mean, at the deepest, most fundamental level, what is the vacuum actually made of? For that, we have to go even deeper, into the quantum realm.
The theory proposes that the very fabric of space is something called the Information Resonance Network, or IRN. You can kind of think of it as the pixels of reality. It's this huge, invisible grid of tiny quantum units that are all connected, making up everything we call space.
So, to picture this, imagine that all of space is filled with a grid of tiny little quantum compass needles. In empty space, they're all just pointing in random directions, total chaos. But when you bring in some matter, its gravity acts like a huge magnet, and suddenly all those little compasses start to align. That collective alignment is the vacuum polarization we've been talking about. So this grid of spinners is what our cosmic styrofoam really is. And this isn't just a fantasy, it's based on well-established models in physics.
Okay, so now that we have all the pieces, from that quantum network all the way up to the atomic halos, let's zoom back out to the galactic scale and see how this finally solves our ghost story.
And here it is. This is the big aha moment. That first bar on the chart, that's the gravity you get from just the visible matter. As you can see, it falls way short of what we need. But then, when you add in the extra gravity you get from the polarized vacuum, look at that second bar. It's a perfect match for what we actually observe. No extra matter needed.
So, if this theory holds up, the ghost of dark matter just vanishes. Poof! It was never there. We weren't missing a substance, we were missing a fundamental property of space. The answer was hiding in plain sight the entire time, woven into the very fabric of the universe.
Now, for any new theory to be taken seriously, it can't just fix one problem. It has to work everywhere the old theories did. And this is where this idea gets really impressive. It perfectly reproduces all of the successes of Einstein's general relativity right here in our solar system with incredible precision. It gets gravitational waves right, it passes all the old tests, and it solves the new one.
But you know, the true science of a great scientific theory is that it doesn't just explain old mysteries. It makes new, bold predictions that we can actually go out and test. And this framework does exactly that.
The theory makes this really wild prediction called gravitational decoherence. It says that because this quantum vacuum is so active, it's constantly interacting with everything. For really fragile quantum systems, like a particle that's in two places at once, the vacuum itself basically acts like an observer. It looks at the particle, and that act of looking forces it to collapse into one single reality.
And here's where it gets mind-bending. This means that the answer to a galaxy-sized problem might not be found with a giant telescope, but in a tabletop quantum experiment right here on Earth. The fabric of the universe could be influencing our lab results every single day.
And this isn't some vague idea. The theory makes a concrete numbers-and-all prediction. For instance, if you take a big molecule like a C70 buckyball and put it in a quantum superposition, this theory predicts that the vacuum will force it to collapse in just half a nanosecond. That's an astonishingly precise prediction that scientists can and are working to test right now.
Which leaves us with this incredible final question. We've always thought of the vacuum as empty, as nothing. But what if this theory is right? What if it's the most important something in the entire universe? An active medium that's literally generating gravity? Could this hidden quantum network be the key, not just to dark matter, but to all of our other biggest cosmic mysteries? The investigation, as they say, is just getting started.